Um, Ladies and gentlemen, welcome. Welcome to Lincoln University. Welcome to B-Link Innovation. Today, really exciting to have Jenny Webster-Brown with us talking about our land and water. But before we go into me introducing to Jenny, a couple of things that I want to tell you. This event is brought to you by B-Link Innovation. We are a full business unit of Lincoln University, and we basically do three things. We connect people, and hopefully by connecting people, people will actually start to collaborate, because when you start to talk to people, you probably find out that you have similar passions or ideas, and then suddenly actually collaboration actually starts. We are a true believer that when you have a collaborative approach, that then the real innovation actually takes place. So that's basically what we do here at B-Link Innovation. And one of the things that we do is organize events. And you are part of the Vibe series. A lot of you would know the Vibe series as being a face-to-face event where we actually offer drinks and nibbles. But also we get a lot of feedback. Can you please do these alternatively online as well, so that a broader audience can actually be in attendance? So some housekeeping. I would assume that everybody is safe where they are and know where the emergency exits are for where they are. From a virtual point of view, this webinar is being recorded and will be emailed out to you, so that you can just sit back, relax. You don't need to have to take notes, because you can actually look at it again. At the end of the webinar, or during the webinar, when you have a question, please fill out the Q&A in the Q&A button. It will be at the bottom of your ribbon. Click the Q&A button, and you can actually type your question. At the end of the talk, we will actually start to address those questions, and hopefully Jenny will be able to answer them. You are all muted, but please use the Q&A button to interact with us. That's absolutely fantastic. Now, the bit that you really wanted to hear is, of course, the introduction to our speaker for this evening, which is Dr. Jenny Webster-Brown. She is the current director of our Land and Water, a National Science Challenge. And her career is basically acting as a water quality specialist for the last 40 years. And it's teaching, research, consultancy, but always focusing on the impact of land use and how we actually look at our resources in the context of freshwater systems. We worked at a number of institutes, but we were really happy in 2010 when she decided to move to Canterbury. So now she is really close to us, and she is working. So she basically took up the position of Professor of Water Research Management, and she set up the Waterways Center, which is a collaboration between the University of Canterbury and Lincoln University. And I think I've said enough. Jenny, over to you. I'll stop sharing, and you can share your screen.
Thank you. Right, I'm going to assume that I'm sharing the correct screen. Please correct me if I'm wrong.
Yes, you are. We can see that. Thank you very much.
Excellent. Thank you. I've gone one slide, one way. Sorry, I jumped ahead in the slides. So, kia ora koutou. Thank you very much for this opportunity to tell you a little bit about our Land and Water National Science Challenge. I'm going to present very much an overview of the kind of work that we have done, the kind of results that are now available, and the stage that we're at, which makes it really important that we make people aware of the type of information that's out there and even more importantly, identify some individuals and agencies that can take the information and the resources that we've produced and run with it. Because one of the most important purposes of the challenge is to create impact through research, and obviously the impact that we have must live on after the challenge. So we are hoping that the resources and tools that we've produced can have a life of their own after the challenge, that they can go out there and be used and be useful, and it obviously needs some people to champion those tools and resources. So just to give you, first of all, a bit of an overview of the challenge, its purpose, and how we have operated, and the stage that we are now at, which is, of course, relatively close to the end of this challenge experiment. Then I'm going to run through some key examples of some of our research outputs and tools. I've tried to pick ones that I hope will resonate with many of you, but also show you where you can go to find out a lot more information. So as many of you will be aware, there were 11 national science challenges set up around 8 to 10 years ago. The topics were chosen for the challenges in response to a public survey. To a large degree, the public was asked what are the most important questions that science can help us answer. One of those was, of course, how we use our land better and in a way that does not impact on our freshwater systems. And that was the building block from which our Land and Water National Science Challenge sprang. All of these challenges, and we do have quite a lot of collaboration between the challenges, all of these challenges end in June 2024. So we have just over 12 months to go. And there's a lot that must be achieved in that final 12 months, as I'm sure that you can imagine. This was very much an experiment, a government experiment, in developing a funding mechanism that would bring researchers together to address particular questions and particular topics. And that bringing of researchers together was meant to transcend boundaries between universities and CRIs, so we can literally pick the best researchers in New Zealand to work on particular projects, as long, of course, as they have time and can make that commitment. So coming back to our land and water and the question that we have been given to answer and the way that we have approached answering it, we see the need to have a transformative vision, one that shifts our current land use, which is all about sheep, beef, and dairy use of land across New Zealand. Something like 90% of our agricultural land is dedicated to that land use. Can we move that to a more diverse mosaic of land uses that are more resilient, healthy, and prosperous than today, and at the same time provide a state of our land and water that New Zealanders are proud of? This has led us down a pathway to looking at combining land uses on a smaller scale, so moving away from the current approach we have of, one area, one purpose, such as potatoes being grown in Pukekohe and kumara being grown in Dargaville, dairy being done in Southland and Waikato. Can we mix it up to a much greater degree? That emphasis on resilience, of course, is ringing very true to us at the moment, since we have experienced these climate events that have shown us how vulnerable we are if we grow one particular thing in one particular area, such as, you try buying kumara at the moment, given that a lot of the kumara crop went down the river in Dargaville. So we see it as being able to address both freshwater and some climate change adaptation issues. Our focus is very much on the agri-food and fibre system. It's on intergenerational solutions, so providing a better way of earning a living off the land for future generations. And it has had Te Ao Māori, a Māori worldview, at its heart. because we do not want to be putting solutions out there that are going to drive Maori and non-Maori land users in different directions. So we have tried to nest our research within that Maori worldview, take us all down a more holistic pathway. The way that we have operated, and again, I think many of you are probably aware of this, we have taken the $96 million that we were given by the government to invest in this area, and it has been invested in three main types of research endeavours. One is think pieces, which are funded to the tune of around 100,000, which are to generate ideas, to see whether particular ideas have got legs that are worthy of a bigger effort, a bigger research program. We have funded working groups, which is one step up for research issues that can be addressed in a relatively short time frame by a smaller group of people. And we have research programs, which tend to be in the 1 million to 8 million investment bracket, which are the multi-year big team efforts on particular topics. Those investments are made across three key themes for the challenge, which I'll go over in a minute. We also have a number of research efforts now being funded under strategic and impact extension initiatives, which is really just making sure that we do get the most out of the research that's being done by putting smaller quanta of funds into particular areas to optimise the impact that we've got. As you can see from the somewhat fuzzy graph, I apologise, we are in a position now where most of our money is invested. Over the last 3 years especially, the amount of investment we've made has gone up significantly. We have now allocated all of our research funding except for those small amounts in impact extension and strategic research, which we can still fund. It's been a spectacularly busy time over the last 3 years, as I'm sure you can see. Okay, thinking about those three themes that all of our research investment has been under. The first theme, and the one that was funded to the highest level, 23 million, is very much dedicated to providing the information to underpin land use change. So it has looked at what kind of diversity of land use is possible. Can we match that land use to opportunities to improve our environmental performance, to support the well-being of Te Taio? It's about developing the models and the maps and the tools to understand that link between the management of land and what happens in our water systems. And it has sought to identify what uses of the land are of highest value to New Zealand as a whole. And that has included looking at how we can grow a nutritious diet for the people of Aotearoa within the confines of our land mass. So can we grow everything we need for a nutritious diet in New Zealand in New Zealand? The second theme is more based on how we can incentivize land users to change how they use their land. So I've heard this described as providing the carrot rather than the stick. How do we make land users start to think about what they could do differently? What signals they should be responding to, and I'm thinking about not just market signals, but also other signals that they can, that they might seek to drive a land use change, and that those signals might be more incentives, might be more in the category of sustainable production, ethical responses. They can encompass a variety of decision-making tools. We're looking at co-creating approaches to land management that might encompass reciprocal and mutual rewards rather than just financial rewards. And looking at how we link metrics of land management to the kind of rewards that you can get. So I will go through some tools that have been generated here, but Lincoln University especially has had a very large contribution to this particular theme in terms of their agricultural economics research unit's work on value chains and drivers, market drivers. The third theme is very much about how we scale up change. We can all think of examples around New Zealand of people doing things differently on their land, of mixing it up, of improving their environmental performance. You've only got to watch Country Calendar for a few weeks to realise that there are lots of examples of individual land units making changes that we need. How do we scale that up so it becomes a nationwide change rather than a local change? Also, what are the obstacles to people making those changes? What are the problems in the system that people cannot get around? So if they want to change their land use, what prevents them from doing that? Is it banks' criteria for lending money for new ventures? Is it the infrastructure that is or isn't there in their area? Identifying where those leverage points are and seeing how we can address those obstacles. Right, this is the really important part. I mean, that's just all about how we operate. The really important part is that we have a repository of all the information that has been generated by the challenge so far and will be generated over the next 12 months. And we have done a lot of work recently to make that far more accessible and more searchable. And so I would very much like you take nothing else away from this presentation to you today. I would like you to remember that there's a website out there and preferably how to locate it. And it is just a wealth of information, of tools and resources and information and journal articles and technical reports and little interactive widgets and maps that are designed to help this process along. It is searchable by using the nature of your interest. So what do you represent, a catchment group, an NGO, a regional authority, and then you can select keywords and refine a search to give you the most useful information. It's also searchable by clicking on Our Science from the menu at the top and looking through the research programs that have been undertaken. So if you know of a particular research program and you want to find out what it produced, this is the best way to do it, to click one of these themes, which will then take you to all the research programs that have been done under that theme and everything that's been produced in that program. Right, I'm going to run through some examples of research output. I've grouped them under some of the frequently asked questions around this topic area, so you can see their relevance, see where they might fit in. This is by no means a complete look at what we've done. Obviously, I've just picked out a few high points. I'm more than happy to take questions on these and point you in the right direction to find further information. So the first question is, sorry, the question has actually become hidden for me underneath the Zoom instructions. Where are the farms and catchments that are of greatest risk of leaching contaminants into our freshwaters? So where are those pressures on our freshwater systems? An example of a tool that's been produced to help people gauge this is an interactive map for nitrogen leaching. And our ability to address that leaching through mitigation. So this is a little swipe left, swipe right type interactive map, as shown here for Canterbury. On the right, we've got the excess of nitrogen, so you can see for the Waimakariri and Selwyn catchments that are shown there, we do have a huge excess of nitrogen being produced, kilograms per hectare, through leaching. Can we address that with mitigation? If you swipe that bar to the right, it will show you in ever deepening shades of blue how much of a reduction you could achieve by using all the mitigation strategies that we have to hand at the moment. And you can see that the scale of that is quite fine. There are areas where you could achieve anything up to a greater than 50% reduction in nitrogen loss, or you can get less than 10% if you're in one of those areas where there's not much that mitigation will do to help you. Another tool in this area is the landscape DNA work. This is it's a more flexible approach to this. It's not just focused on nitrogen, and it is a nationwide map system. Many of you might be more familiar with it as the physiographics system, which our Land and Water funded in phase 1 of the challenge. And it allows you to drill down into an area or a catchment of interest to you, and it will give you the overall rock and soil and landscape characteristics of that catchment and how that will affect aspects such as contaminant loss from that catchment and water flow. It will also allow you to identify some actions that can be taken in that catchment and which ones are likely to work the best given that landscape, to reduce contaminant losses in that catchment. It purports to go down to farm scale, but in fact a lot of the data that supports the landscape DNA system isn't actually, doesn't quite have that resolution, but it still can provide you a pretty good indication of what your problems might be in a catchment and why those problems might exist. Following that same theme of mitigation, how can we decide what mitigations might be most effective for our particular land use? This is another little interactive tool which has proved to be extremely popular, and that is actions to include in a farm environment plan. And it allows you, for your particular land use, in this case dairy has been selected, across the various contaminants that may be generated from your operation: phosphorus, nitrogen, sediment, greenhouse gases, and E. coli in this case. It allows you to identify which of the mitigation actions will be most effective and lowest cost for you to implement. So it's obviously a sort of first pass attempt at that decision that needs to be made, but it has proved to be extremely useful and has allowed people to follow up on particular actions that are going to prove most worthwhile for them. That brings us to the question of how do we know what has already been done in a catchment, because this can be planting on farms especially. It's not a very transparent process. There could be quite a lot of planting done and no one knows about it. So there is a research program, which is just concluding now, which is designed to provide another module for the LAWA website, which provides, of course, a lot of land and water information already. And it will show you how much riparian planting and other mitigation has been done in a particular catchment. Once you select that catchment, it will give you key information on the catchment and talk about how many kilometres of river have been planted and other metrics of mitigation completion. We're really looking forward to seeing that get out there. It's going to be a very useful tool for showing people where they sit in the mitigation journey. Question we often get asked, well, has mitigation done us any good so far? You know, a lot of money has been spent on things such as stock exclusion and planting trees and wider riparian planting, conserving soil, shifting to more precision irrigation methods, treating effluent, etc. Has this made any difference? Some work that was published a couple of years ago from our Land and Water showed that, yes, it has made a difference. It has been able to reduce the impacts of dairy on nitrogen, for example, by about 45% and even greater for phosphorus. So we might have expected at this stage over the last 20 years to have seen much greater nitrogen and phosphorus leaching from the land than we are seeing, and that difference is due to mitigation. Unfortunately, it has been offset by the increase in land use dedicated to dairy, especially. So we've still seen an increase in nitrogen and phosphorus loss, but it's not as bad as it could have been, I guess, is the take-home message there. Can mitigation solve our problems? Again, that same publication a few years ago has shown that if we project forward to 2035, taking account of all the mitigation that could be done that we do already, so spreading what we know already into every situation where it can be used, and implementing developing mitigations. A lot of catchments in New Zealand, most of them would be able to meet the dissolved inorganic nitrogen bottom line that was proposed a few years ago, not implemented in the NPS freshwater management, but it is still a bottom line that is likely to be implemented at some stage. About 90% of the catchments could meet phosphorus bottom lines. But a key take-home message is that there's certain areas that are not able to meet it through mitigation. And we've got small catchments up north. We've got most of Canterbury, unfortunately, and a lot of Southland. So there are key areas in New Zealand, and they are the areas where nutrient losses are most of greatest concern. Mitigation is not going to be the way forward. Doesn't mean that it shouldn't be undertaken. Obviously, it should be. But we're going to need something else in addition, and that something else is, of course, going to be land use change. So what could we change the land use to in these areas where we can't address our problems through mitigation? We have a very large, in fact, one of the largest programs we fund is a program called Toiora, or Land Use Opportunities. And this builds on a previous program, Land Use Suitability, is looking at precisely this question. What are the alternative crops we could grow? How will they benefit us and benefit the freshwater environment? And a particularly useful tool that's coming out of this at the moment is the supermarket database, which is a large geospatial database which lists all the potential crops that could be grown in New Zealand, or as many as we can get information for. And their requirements in terms of soil and climate, etc., and provides people with a look over what their options might be. Okay, if you can't do dairy in that area anymore, what else could you use that land for? This would be our first stop on that journey. This is currently hosted by Whenua, who are one of the partners in this particular program. They haven't committed to be a long-term host for this, so we are looking for alternative hosts at the moment. So we want to achieve land use. How do we help people see that they can make a change and remain on the land? We're not obviously pushing for people to walk off the land in great numbers. One of the key components here is trying to learn more about the signals that land users respond to. What do they use in their decision making about what their land will be used to produce? We have a program called Signals for Stewards, which is a working group which is just finishing up now, which is providing us with some information on that. Some of the signals we know they respond to are obviously market signals. What are consumers asking for? What are they looking for? What are they prepared to pay for? Particularly in international markets, given so much of our produce is exported. And Agricultural Economics Research Unit at Lincoln have done a lot of work on matrix of drivers. So what are those drivers? They produced recently an online tool that allows people to see what those drivers are and what impact they might have on their decision making. We're also funding work on alternatives to market drivers and financial drivers. Ethically or culturally driven change and land use is an important consideration here, particularly for Māori who are moving more to land uses and ways of managing the land that are more consistent with a Māori worldview. And we have funded work in the Ngāi Tahu Research Centre with John Reid to look at that. Ensuring that we can capture the value. So if people make these changes, if land stewards make these land use changes, moving to a more sustainable, moving to a more ethical, moving to a more cultural way of producing from this land, can they realise that in terms of a reward? How are things linked through the value chain to make sure that people do realise those rewards? And the Value Project was a big effort which has now finished, and there's a lot of information on our website on how to capture value for sustainably sourced products. And they came up with 9 attributes of a very successful value chain to allow that connection between making change on the land and realising the value from the produce. Scaling up. How do we make sure these changes don't just occur on a farm every now and again? We've got another very big program called Revitalising Te Tao, which takes 3 case studies of businesses that are trying to do things differently at different stages of their journey, and is using the lessons from these journeys to inform that scaling up process. So one of these is an agri-based venture in the Bay of Plenty and Waikato, which is looking at ways to enhance the mana and Māori of soil across 10 dairy farms. They are fairly advanced on their journey. Another case study is looking at a group in Wanaka, again dealing with traditional farms and traditional farm plans, and looking at ways that these can be adjusted or encouraged to include the benefits for the environment in their operation. And the youngest or the newest of these ventures is a Taranaki-based group, Te Kahui Rau, who are looking at revegetating and reusing a large area of Māori land to support the iwi and hapu of the area. That program does not finish until the end of this year or early next year. It was rather a late starting program, but we're hoping that we will have a lot from that program to put out there to help people make these changes. Acknowledging that a lot of changes on land are going to come in response to the policy, and there are many policy changes coming down the pipeline to farmers at the moment, as we all know. We have put out guidance for those that are required to be changing how they do things, help on how to design an effective farm plan, and farm environment plan, especially emphasising the need to get together as a catchment, because the changes that occur in freshwater systems in response to on-farm changes are going to occur at a catchment scale. So guidance on how to collectively think about the issues for your catchment and how to make those changes across several farms or all farms, preferably within the catchment, to actually see a change. Also guidance on Te Mana OTY, which is a concept which was embodied in the National Policy Statement for Freshwater Management, and does have a very high profile in that policy. The implementation of that is not something which is very straightforward. And we funded Tina Puro, Ngāti Puro, to provide some guidance, and she worked on a number of case studies showing how iwi and regional councils could work together to implement Te Mana Utiwai in those areas. She has now moved on to looking at how to train iwi to engage constructively and provide them with the knowledge they need to be able to create the change that they need when working with regional councils. Who are going to be the agents of land use change? We are seeing, as many people are seeing, that catchment groups are a key factor here. So we've just finished now a big research program with Cawthron called New Models of Collective Responsibility, which is looking at what catchment groups need to operate most effectively. And they've come out with a number of recommendations. In fact, there was a webinar yesterday from the lead of that program, Jen Sinner, who conveyed those recommendations both to catchment groups that are starting out about what they need and what they're going to have to sort of put in place from the start to be effective, but also for the agencies that support those catchment groups, especially funding agencies, as to what they're going to need in terms of continuity of support. So we're building on this now with further work on catchment groups and funding structures that would be most effective for them. I think one thing we all forget, we think all catchment groups can do this, that'll be great, but they are all volunteers. They are all land users who are getting together on a voluntary basis to achieve this change, which is so necessary for New Zealand. So all the support that they can get is needed. Okay, if we are able to achieve this change, and let's hope we can go some way towards that, how long will it take for land use change to be reflected in changes in our water quality? A key factor in this is, of course, the lag time that occurs between the application of contaminants to the land and the signal that is then seen in the river water for large catchments or the groundwater. Work that has been done largely by Rich McDowell, who's the chief scientist with our Land and Water, to try and quantify what the average lag time is for New Zealand, has shown that it's around about 4.5 years. So that's the time between application to the land and turning up in the river. Obviously, it does depend on the nature of the catchment, the size of the river, etc. So that ranges between 1 and 12 years. The fact that it's an average of 4.5 years is it shows us that the timeframes in the National Policy Statement for Freshwater Management are not unreasonable. It's a 5-year timeframe given in that document. But it does show you that we're unlikely to see improvement in at least half of our major catchments in under 5 years. We are currently doing some work, Rich and his colleagues are doing some work on what that lag time is for groundwater systems. This is instrumental in helping catchments not develop false hopes about how fast they will start to see freshwater improvement within their catchment, because the last thing we want to see is a huge amount of effort and incentive go in with catchment groups and then they get dispirited because nothing seems to be happening for a long period of time. So if we can quantify this lag time to a greater degree, it gives them more realistic expectations of that time frame. How do we go about detecting that water quality change now that we know the time frame in which it may occur? We have a very active program led by Olivia Osell of Aquanet that's looking at how to design the most effective monitoring programs to detect change in the shorter term. And part of the outputs from this will be an interactive map, again, that allows you to select obviously the contaminant that you're interested in, a duration of sampling, in this case, for this particular case here, it's 5 years, how frequently you will sample, the desired change that you want to be able to detect, say a 20% reduction in nitrogen for this case. What are your chances of being able to do that? So you can see that across New Zealand for this particular scenario, our best chance of being able to see that change is happening in Canterbury, around the central North Island and in Southland. This obviously is accompanied by a lot of information about the types of inputs you need when you're designing a monitoring framework, and what kind of outputs you can expect. And it will tell you, give you information on cost, as well as, you know, where to place your monitoring sites for the most effective outcomes. That is not quite finished, the interactive map side of that. It will be later this year. I think that is likely to be the most of what I want to tell you. I think I'm largely on time. Thank you for your attention. And part of our reason for doing this, of course, at this point, is because we're hoping to identify people out there for whom some of this information and tools and resources resonates, and you can use it. And it is all open access, and we are very keen to connect to the people who want to use it. We can offer training and help and support if it's needed. But we need those champions to take our information out there into the world after we're gone. Thank you.
Jenny, thank you very much for this very insightful presentation. And what I really like is that everything is open and transparent, so that everybody is actually able to access the investment that we made into our land and our land and water. For the people online, please use your Q&A button to ask questions. I've seen one question pop in, so I will start with. Before I start with that, I have a question to Jenny. Jenny, you said that it takes about 4.5 years from application to on the land, and when we actually going to detect it into the water on average. Does that mean that if we would stop application now, we would have no more pollutants in our groundwater in 4.5 years' time? Is it as simple as that?
The 4.5 years is for surface water systems. So if you were to turn off the tap now, on average across New Zealand, you could expect to see that change in freshwater quality in 4.5 years. It would take between 1 and 12, depending on which catchment you're in. For groundwater, and I wouldn't preempt the results that they're going to find because that work is still underway, but it will be a longer time than that because of the nature of groundwater flow, groundwater systems.
So in other words, whatever we're doing today, whether it's completely drastic and closing the tap 100% completely, or all the smaller things, this will be with us for a long period to come. Yes.
Yes. Yeah. Depending on what you consider to be a long period.
Correct. Yeah, touche. Yeah. Okay.
Yeah, and that is part of the reason for that work, is not so much to, you know, give a number, but to make sure that people don't have unrealistic expectations of how fast change can occur.
Coming to, thank you very much, Jenny, for that. The question that I have in the Q&A at the moment is from Trevor, and he was probably in the webinar that you referenced as well, Jenny, of yesterday, and the DNA catchment tool was not mentioned. And his question was, is there a disconnect?
I hope not, Trevor. The DNA catchment tool is available for everybody to use, and I would imagine it will be being used already by a lot of, well, I know it is being used by a lot of farmers and a lot of catchment groups already. The webinar that was given yesterday was largely around how catchment groups function and supporting them to develop effective plans for what they want to do and identify consistent indicators that they want to monitor. So it wasn't so much about how they make decisions within their catchment itself. It was more about the structure and framework in which they work to make them more effective. So it's not a disconnect. Jim Sinner, the person who gave the webinar yesterday, is definitely aware of the catchment DNA tool. It's one of many such tools. It's not the only source of information on a catchment's characteristics. But yeah, I have no reason to believe that they are unaware of each other's programs.
Thank you very much, Jenny. Another question now from Jane is, she's asking for monitoring of effectiveness tool on your last slide. She noticed that the daily monitoring is being the input. Is this based on modeled data giving the limitations for current frequency of the monitoring?
Yeah, that's a good question. That was simply a scenario really to show that if you monitored those catchments daily for 5 years, you would have a chance of detecting a 20% reduction in nitrogen. You could change any of those inputs. You could make it, monitoring once a year for 5 years, which would, I'm sure, show you that you had zero chance of detecting a reliable change in nitrogen concentrations. So please don't take anything from that to suggest that you should embark on daily monitoring. However, it is a reflection of the fact that a lot of our monitoring programs at the moment monitor far too infrequently to give us trends in a useful time frame. And with the invention and the more frequent use now of continuous monitoring devices, particularly for things like nitrogen, we do have the ability to monitor more frequently. And, so daily monitoring may not be as out of the question as it has been in the past. I hope that answers your question.
Thank you very much, Jenny. Michael has a question that he is basically talking about the natural occurrence of nitrogen in our water, and are we taking that in consideration?
Yes, we are. Yeah, certainly agree that water systems have background or baseline concentrations of all of the contaminants that I have talked about. And we need to take that into account. Obviously, nutrients are nutrients, and if water didn't contain things like nitrogen and phosphorus, it wouldn't support life of any kind. But the way that the lag times was calculated was based on looking for the increase in that concentration in those rivers. When did that occur? And comparing that to the increase in the application of fertilizers or E. coli sediments on the land, and when did that occur? So what was the time difference between those? So it wasn't looking at absolute nitrogen and phosphorus, etc. levels. It was looking at when that change occurred. So the baseline definitely was taken into account there.
Thank you very much. John has a question. When he thinks about the different lag times for the different catchments, are we better, if we had a choice to make, to prioritize action addressing catchments with longer or shorter lag times?
That's really that's more of a philosophical question, isn't it? I mean, if you choose catchments with shorter lag times, it would be more encouraging for people to actually change land use and try to improve things. However, you know, there's no better time than the present for dealing with catchments that are going to have long lead times. So yes, I think that's possibly just a bit above my pay grade in terms of philosophy there.
There is somebody online that choose not to give their name. Question is, there is a lot of work on farmers changing what to do and or land uses, almost in isolation from other parts of the broader system. Has any work been done on how institutions need to change or change things they do to nudge or incentivize the changes required?
That's a good question too. Depending on what you mean by institutions, I think one interpretation of that institutions would be the industry bodies that exist in the primary sector. You know, obviously dairy farmers affiliate with Dairy New Zealand, and there's other groups that bring together, Beef and Lamb, that bring together all those farmers of a particular type to help them with their operation and to get value from what they do. We have found, because of the approach that we are taking, which is diversity of land uses and moving to different land uses and mosaics of land uses, that can be quite difficult to convince those industry groups of our approach, because they obviously have a lot invested in keeping their farmers on a dairy track or on a beef and lamb track. It's not something that we've given up on, and obviously I'm speaking generally here. There are people within Dairy New Zealand and Beef and Lamb that are thinking very inventively around this. So yes, there is work being done. It is quite difficult to nudge those industry groups in a different direction. It's just not in their best interests.
Wouldn't you say, Jenny? I'm just thinking up loud, right? Growing up on a small little farmlet where basically we use mixed agriculture, so horticulture, orchards. We had livestock. We were milking cows, etc., etc. So the whole mixed system. Would you argue that at the moment, our current situation, when we see, for example, fertilizer prices going through the roof, that those are actually natural moments of change as well, that our agricultural entrepreneurs, our farmers will actually think, okay, this is no longer worth our while from a cost perspective. So is that a driver that actually will push people into a natural land use change?
I hope so. I mean, you know, part of our purpose is not to drive the change ourselves, but to be ready to respond with alternatives and decision-making support when the change has to be made. And that change may have to be made through a number of different drivers. You know, the dairy milk price, for example, is one, milk solids price. That goes up and down. It affects the financial viability of dairy operations hugely. They may change because of that. Fertilizer costs are another. There's many other, and climate change is another. I mean, we're hoping very much that some of those areas affected by the recent cyclones, once they're through the current crisis, will be able to think more strategically about what they could do with their land that might prove to be more resilient. And we want to be there with the advice for them when that happens.
So I think that is a beautiful moment to actually end your presentation, Jenny, because basically what you're saying is there is a lot of change coming toward us, and through your program, Our Land and Water, you have provided the sector with a tremendous amount of tools so that the actors in our sector can actually come up with hopefully some balanced and some good answers.
Well, thank you. I hope that was my purpose. You know, it is just a showcase at this stage. It would be great for people to jump on the website and have a play in there and see how much there is and work with some of those tools. And I'm more than happy to give presentations. I see there's one question, would be prepared to give one to the Rural Advisory Panel. Yes, I'm more than happy to make people aware of what's been done and what it can be used for.
Jenny, thank you so much. And yeah, I saw that question as well, but I thought I was gonna post it to you after the meeting, but that doesn't matter. Thank you very much for being with us, Jenny. Before you leave us, I like to invite you to the next series, which is an innovation series, when we're actually going to talk about sustainable finance, because again, we need money to actually fund these changes. Another virtual event on the 27th of April, and you're all very welcome. The next one is on the 10th of May, which will be in person, which will actually celebrate the research excellence done at Lincoln University. And we will actually have Professor Kevin Moore talking to us of the challenge of living well in today's world. And with that, I like to thank you for being with us. Please give us feedback on our social channels. And thank you very much, Jenny Webster-Brown, for being with us, and all the participants online for listening in to us. Thank you so much, and see you next time.